My name's Ian Massingham. I work in the AWS evangelism team, spending my time trying to help developers understand how they can build products, applications, and other services on top of the technology that AWS provides. So that's the role of myself and my team. And this session is an introduction to Amazon Lex. We're going to start with a little bit of the backstory of conversational interfaces, why I think they're significant and why I think there's a very significant change in the way in which applications are being built at the moment to take more advantage of this kind of approach for accessibility and also to integrate applications and data sources into people's natural lives in a more effective manner. And that might be people's natural working lives, but it's also increasingly their personal lives as well, for making access to applications and information sources more natural. We're then going to move on, talk a little bit more about what Amazon Lex is, how it's constructed, what the different components of the service are, and what some of the concepts and mental models that you need to adopt in order to build applications using this tool are. And then we'll dive into the console at the end. I'll show you provisioning an intent using Amazon Lex, hooking that up to AWS Lambda, and I'll show you some of the instrumentation that we have to help you monitor and debug applications that you've built this way as well. First thing though, why did we build Amazon Lex? There's a couple of things here. The first thing is we have a precursor to this service, which is a physical device called the Amazon Echo, which a lot of you will be familiar with. Comes in several different form factors. It's a voice-controlled speaker that you can interact with using natural language, and you can ask it questions, give it commands, and it will do helpful things for you. Like for me, it will set an alarm and tell me what the weather forecast is going to be tomorrow. As an Englishman, of course, I'm obsessed with the weather, as you'll all know. For my children, it will answer this following request hundreds and hundreds of times a day. Alexa, please play Black Magic by Little Mix. Okay. If I look at my account history in my Echo, all I see is that phrase repeated over and over and over again. Thankfully, I don't have to be in the room to drive the audio system, so it's fine. It protects me from bad music. But my 5 and 7-year-old girls can interact with a service, Spotify, using their voice. Okay, something that they probably couldn't do if they had to use the tablet-based interface, particularly for my 5-year-old. She's still pretty young for that. So what you're seeing here is that this trajectory of simplifying interfaces, it allows applications to be embedded into people's natural lives. It allows them to be accessed and controlled using the most natural interface of all, which is speech. Okay, and now there can be good reasons for that around accessibility. I actually saw something quite moving myself at a user group, AWS user group that I was at in Dublin, Ireland, where a disabled person with a visual impairment, they could barely see, was talking about how using voice-based interfaces has completely transformed his life and completely transformed the life of his family. He no longer had to trouble his wife with simple information requests. He could just ask Alexa, and Alexa would find the information for him and return it to him. It also made things like transportation accessible for him, because he could do things like ask about bus timetables or even order an Uber using just his voice. I can say that I wasn't the only person in the room at the end of this talk that had tears in their eyes hearing how something as simple as a new interface mechanism could really transform the way in which someone lives. So there's a big component there. The other thing we see, of course, is embedding information sources and applications into safety-critical environments, or environments where distraction can be a big risk. I'm sure you've all used audio sat-nav in your car to say, navigate me to my place of work or navigate me home again. It's just much safer than tapping into a traditional display where you might have to be distracted from the road and take your eyes away from driving. Well, there are lots and lots of other examples like that. Wouldn't it be great if we could give workers in safety-critical environments access to information using voice? Okay, it's not a mass market application, so building something like that probably isn't practical or economically viable if you have to build everything yourself. But if you have a framework, a platform upon which you can build conversational interfaces, you can bring that kind of convenience and safety of information access and control into other kinds of workplaces, into other kinds of environments where there are a lot of benefits of doing that. So it's not all about, making products which are less frictionful and easier for people to access for profit, there's also some really good societal safety, accessibility benefits that can be delivered by specializing in this area. And that's one of the reasons that I personally am pretty excited about conversational interfaces, about the opportunity that it opens up in a broader sense. So that's a little bit of the why. Some of the things that are difficult to do here, okay, and you'll know, you've probably heard this phrase from a lot of different people working at Amazon: avoid undifferentiated heavy lifting. Has anyone ever heard that before? No, really? Oh, you've never been to an Amazon event then? Okay, so we always say that. We always talk about removing undifferentiated heavy lifting. I like to think about it like this. Don't build a platform unless you're building a platform. Okay, so if you're building products, use platforms. Don't repeat work that others have already done. Focus on things that are genuinely unique and provide differentiation and value add for the companies that you represent, or for the objectives that you're trying to achieve. And there's a lot of opportunity for this in conversational interfaces. There is a lot of heavy lifting associated with things like speech recognition, NLU, natural language understanding, instrumentation, messaging, API-based access, interfaces that you might need to build to other systems. Well, every chatbot developer needs a Slack and Facebook interface. So why is every chatbot developer going to repeat the same work? Why not use a platform that has these common capabilities embedded within it, and spend your time designing your interface, designing the intents that you want to work with, the workflows that you need, and the custom integrations that are required for your particular app. Okay, and that's what we're trying to do with Lex. We're trying to allow you to offload all of the heavy lifting that everybody has to do. Focus your time and effort, the time and effort of your development teams, on the specifics of the conversational interface that you want to build. What do I need to know to enable a user to check the status of this piece of industrial equipment? What do I need to know in order to simplify the process of booking travel, ordering flowers, making a retail purchase? What are the data models that I need to manipulate, and what are the interfaces that are required to express the functionality that I want to build? And that's where we think developers should be focusing, not on building and training their own neural network models for natural language understanding or for speech recognition. That's something that is common and can be implemented as part of the platform. So that should give you a clue as to some of the things that we've built. So we've built uncoupled some of the text and natural language understanding capabilities within the Echo, within the Alexa voice service, which is the front end of the process that occurs when you communicate with an Amazon Echo. There's the Alexa voice service. It receives your spoken word, an audio file essentially from the physical device, and it decodes that and converts it into a data object. That is what the Alexa voice service does. We've unbundled that and made it available for developers within Lex, so that you can send Lex audio files, objects containing speech, and convert those audio files into object-based representations of their meaning. Okay, so that's what we have there. Deployment to chat services, those repeatable activities around integrating with Facebook, with Slack, deployment into mobile devices as well with mobile SDKs. We've built some capabilities around workflow for application development, which I'll show you later, including versioning and alias support. We've built these enterprise SaaS connectors. This allows you to connect your chatbots to things like Salesforce, Microsoft Dynamics, Marketo, and other common enterprise information sources, so that you can do things like update contacts in Salesforce using a voice-based interface. And that, again, can be really helpful where you might have a mobile workforce that want to do that from in the car, or collect and initiate email marketing activities within Marketo, once again using a voice-based interface. So we have these standards connectors that have been implemented. These are two terms that are really important. This unbundling that I talked about, taking this technology out of Alexa. And one of the things that it's worth understanding is the difference between ASR, automated speech recognition, and NLU, or natural language understanding. So ASR, what is the sequence of words that I said? I want to book a flight. I want to book a flight. Okay, that's speech recognition. What did I mean? What was my intent? Well, my intent's obviously to book a flight, but the complexity comes from the fact that there are 1,000 different ways to say that you want to book a flight. Okay, I want to book a flight. I'd like to fly from London to Tel Aviv. Do you have any flights from Tel Aviv to London? Is it possible for me to fly from London to Tel Aviv next week? Next week, I'd like to fly from London to Tel Aviv. See? Now, you want to write a case for every single one of those? in your system to understand all of the different nuanced ways that I might express the same thing? Probably not. Okay, and this is where the deep learning neural network comes in. The deep learning neural network, which provides the NLU, it's trained to unpick all of the different nuanced ways in which people might ask the same thing, resolve them down to the same base intent, which is book a flight, okay? Unpack the pertinent data objects, we call them slots, the pertinent data objects out of the phrase that I spoke, and pack those up into a data model, which can then be dispatched off to a fulfillment engine and allow me to book that flight that I want to book. And that's where the AI comes into play in this particular service. It is in unwinding the complexity of human speech and turning it into something that a machine can recognize and deal with in a structured way. Okay, so that's really what's at the core of Amazon Lex. Deployment into chat services, Facebook Messenger, Twilio, SMS, Slack, and others. And we also have mobile SDK hooks. And the mobile SDK hooks can be deployed on iOS or Android. They can also be deployed on other connected devices. So you could build audio capture capability into a domestic appliance or into an automotive product, a vehicle or a truck, car or truck, in embedded software, speak to the device, capture audio, and communicate securely with the Lex API endpoint, sending your audio streams to the endpoint for ASR and NLU, and then dispatch onto the execution engine after the intent's been detected. So this is how you would interface a physical product with the service, is by running embedded software on the physical device that captures audio and sends that across to the Amazon Lex API endpoint. On the right-hand side of this slide, you can also see that we've done some of the groundwork associated with displaying cards in these common chat interfaces. So if you've ever experimented with Facebook chatbots, which are text-based chatbots today, you'll know that you can display cards there. You can have interactivity in those cards. You can use the touch interface in the Facebook mobile app to, for example, present 3 different options to a user graphically, 3 different types of car maybe in a car hire transaction, and allow the users to tap on one of the cards within the native Facebook Messenger interface, and that will trigger the next step of a conversational flow with the user. Which car do you want to book? Show 3 pictures. They can hit the mid-size car, a transaction will flow back to the chatbot, and that will move on through the process of making that booking using a graphical interface. So you can jump between text and touch-based interactivity directly within the native apps that your customers could well be using. Same thing in Slack, where you have buttons and you can select options, and again we have the capability for this back and forth. So the natural language interface extends beyond simple voice or chat. You can also use touch in the interface as well. This is the developer experience in the console. I'm going to show you this a little bit later. You'll be able to see it a little bit better. But what you can see here is a multi-part console screen. You enter sample utterances. So how will I invoke this particular intent? Okay. What you're doing here really is priming the neural network with some illustrative phrases that will trigger the intent. So here I would write I'd like to book a flight. I want to book a flight on Thursday. I'd like to book a flight from London to Tel Aviv next week. I would write in 5 or 6 or 7 or 8, as many as I want, different sample utterances, and this gets the neural network started with the capability to understand what it should be looking for in order to trigger this particular intent. I then define my slots, so the specific components of the data model that I need to fill out, the form, if you like, that I need to fill out in order to fulfill this intent at the end of the process. For flight booking, it might be origin, destination, date of travel, time of travel, class of travel, preferred airline. Those might be the slots that I want to populate, and the neural network will then construct the conversational flow that is required to fill out all of the parts of my data model. So if I say I want to travel from London to Tel Aviv on Friday, it will ask me what time I want to travel, with which airline, and what's my preferred class. If I say with BA, it would drop the airline and it would ask me the time of travel and the class. So it will intelligently construct the questions that are required to completely populate the data model that's required to fulfill the intent. Okay, it's quite a sophisticated tool in that respect. And then we have other features around fulfillment with Lambda Functions. Can also integrate with Lambda Functions for more sophisticated request verification request verification customization can be implemented in Lambda, and we could actually go out to third-party systems or other endpoints as part of that verification process. What if I asked for a dentist appointment at 4 p.m. on Friday, but that slot's already gone, that time slot's already gone? Well, I can have my fulfillment logic verify when I have availability and return back a suggestion to the user suggesting that they might like 4:35 instead, because I have availability then. Okay, and I can integrate with external systems to add that richness into the voice interface as well. We have versioning and alias support, so you can have multi-party teams working on developing and enhancing chatbot-based systems, and do that using versioning, so that individual developers can work on different versions, or individual subgroups can work on different versions without conflicting with the version of a chatbot that you may have in production. So this is also implemented within the console and implemented within the API. And you can do alias switching, so quick switching between different versions of your chatbot to switch out versions that are live, versions that are in test, versions that might be in staging as well. So there's a lot of commonality with Lambda there, actually. And then on the interfaces, as I said, mobile SDK integration for both audio and text-based chat. So you could, so you're a flower shop and you've got an application that you distribute to your customers to enable them to order them flowers. Well, you could have a push-to-talk button in there that would enable your users to speak to the app instead of use the touch interface. I'd like to order roses for delivery on Thursday, please. Package up that audio file from within your app, send it to our API endpoint, and that kicks off the intent determination process. And then we get into this back and forth. Where do you want them delivered, et cetera, et cetera. Okay, so that's how you build in using the mobile SDKs. On those SaaS connectors that I talked about earlier, we have support for a broad range of different tools here. And as I said, this is a mechanism for providing users with the capability to interface with enterprise applications using these modern chat-based interfaces without you as a developer having to do all the groundwork to build those integrations. We build it once. Anybody that chooses to use Amazon Lex can take advantage of that feature. So what are some use cases that we've seen? I've already hinted at quite a lot of these already with some of the illustrations that I've been using. Informational bots, application bots to extend mobile applications, enterprise productivity, which we've already talked about, inventory checking, updating contacts, scheduling appointments, all of the stuff that you might normally do with a CRM system, you could do with chat with some of the integrations that I've talked about. And then IoT, domestic appliances, automotive, industrial control systems, any physical device with a speaker and microphone and enough CPU power to run one of our SDKs, it would be capable of being turned into a conversational endpoint. Okay, and you could envisage situations where people, rather than needing home automation systems and hubs and all the complexity that comes with that, just have a microwave that they can ask to turn on. Very simple to build. So maybe you really can have a microwave that turns into a camera. Okay, benefits. So I already talked about this. Offloading this heavy lifting. Our high quality, but also constantly improving text and text-to-speech and NLU engines. Okay, this is I think it's sometimes underappreciated benefit of using AI services of the type that Adrian talked about in his previous session. They get better over time as more and more people use them. The models become larger, the data that we can use for training becomes more sophisticated, and every user of those systems, those services, benefits without having to spend time working on enhancing their own speech recognition system. It's just a natural characteristic of using the platform that over time capabilities improve. There's no scaling concerns. We have lots of integrations with AWS. As you might have guessed, the fulfillment engine at the end of the data collection process that exists here is implemented using AWS Lambda. And if you're familiar with AWS Lambda, you'll know that it has IAM roles, so a very strong security model. It has the capability to deal with things such as cryptographic helper functions for encrypting secrets and other sensitive data that you want to have present in the application environment but not visible. It has native integration with other AWS services like DynamoDB, Kinesis, our ML service, so you can very simply and easily integrate the fulfillment engine that you're using with Amazon Lex, together with all of the services that you're probably already using, together with AWS Lambda. And it also means that the skills that you've developed around AWS Lambda are immediately transferable into the chatbot domain. So if you've got skills in building applications in this way, they're portable into Lex. You can re-leverage those to build sophisticated applications very, very quickly here. And then we have our familiar consumption-based pricing model, which makes it very cost-effective. That's how things look. So you've got your intent, what I want to do. An utterance is, if you want an invocation instance of the intent, where I'm going to say or type a phrase that invokes that specific intent. So each of those examples that I gave about flight booking would be one example of an utterance invoking the book a flight intent. Okay, these are important concepts. The terminology that I'm using here you'll see reflected in the console later. The slots, those items of input data that I need in order to fulfill the intent, and then fulfillment, the mechanism through which fulfillment takes place. Nominally, a Lambda function expressed in one of the supported languages within AWS Lambda that's going to implement the business logic, the other points of integration that are required to make whatever it is I've asked for actually happen. And we have this back and forth model for filling out those slots, as I already mentioned, making sure that we've got the complete data model that we need to conclude our transaction. This confirmation that you can see here, that comes back from the fulfillment logic that you've built. Okay, so your fulfillment function should return back an object which is structured appropriately to be interpreted by Amazon Lex and provide feedback to the user of the system, to the user of the particular interface that you've built. Okay, so we have a data structure that we define there, a model that we've defined, and as long as you comply with that model and create and return objects that are structured appropriately, the return output from your fulfillment functions will be spoken back to the user, confirming that you've made a booking, maybe asking for further input if you've got that enriched model that I've talked about, where you might interface with other systems. You can decide and build whatever functionality you want there as long as you comply with the specification that we provide, of course. Okay, I'm going to skip on a little bit. Slot elicitation. So there's two ways to do this. This is filling in this data model to ensure that we've got the right components that we need for fulfillment. You can do this in simple terms just by defining these slots within the console, or you can integrate with a fulfillment function that has richer validation and provides a greater degree of customization over this slot elicitation process. Okay, so if you want to go beyond very simply asking questions like which city or what time or when, you can build your own custom responses within Lambda Functions and use that to enrich and customize the experience for customers with that fulfillment logic integrated with those return to client models that I talked about a little bit earlier. Right one. So there's a multi-stage pipeline for creating these chatbots, which allows you to save and build and test a new version of your interface before you actually publish it live. So we provide an integrated staging environment within the console. This is where versioning becomes very apparent and very important. We also provide integrated testing capabilities within the console as well, which I'll show you a little bit later on. So you can interact with the bot directly within the AWS console without actually having to establish integrations with Facebook or with Slack or with any other system. So you've got a self-contained test environment. Once you've published, this is the point at which you would establish webhooks for integration with Facebook or with Slack, and at the point at which your API endpoint would become available for you to submit audio intents to as well. Okay, so that's the process for putting live one of these systems. And then we have integration with monitoring and instrumentation. So missed utterances. This is quite interesting. What you can do here is not only see how many requests have been made to your bot which have not been interpreted, but you can actually see all of the detail of all the requests that have been made that have not been interpreted. This can be an interesting mechanism for uncovering opportunities for new functionality or features. Maybe you've got users of your travel booking bot that are asking for other modes of transport that you don't support, or asking for activity bookings that you don't currently support. You know, I'd like to book a hotel for Cape Town for the 29th of July. Okay, I'd like to book a restaurant. I'd like to book some theatre tickets. They wouldn't be supported in the first model if all I'd published was hotel booking, but I can still identify them. So it's an interesting mechanism for gathering product enhancement opportunities actually by looking at the utterances that have been made that you haven't been able to fulfill or you haven't been able to interpret. Okay, that's provided in the system as well. Request latency and traffic by channel, so what's coming from Facebook, what's coming from Slack, what's coming from audio. Again, that might lead you towards prioritizing different features. Yeah. Such as? Yeah, of course, yeah, absolutely. Yeah, so we'll maybe get to this later when I show you a little bit of demo. As I said, when you get the data model complete for the intent, so my hotel booking data model is complete, I have my dates, my location, my chosen hotel, there's an object then which is sent off to a Lambda function for fulfillment. Okay, and that Lambda function is Java, JavaScript, Python, or C#. Okay, and within that I can write whatever logic I want. So if I'm unlikely to book my hotel right there, I'm likely to go out to another API to book my hotel. So that's the normal implementation model. The Lambda function is an intermediary function that takes the object and then communicates with external API endpoints to make whatever's been requested a reality. And this is where other Lambda features like secrets management come in, because you're probably going to need API credentials to talk to that third-party endpoint. What Lambda gives you is a neat way for managing credentials with environment variable injection and cryptography, or you can mix and match with DynamoDB and other state stores as well. So there's a lot of flexibility introduced here because we're using Lambda as an implementation platform. Yeah. Yep. Yep, absolutely right. In fact, I'm halfway through building precisely that thing. So how might you do that? Well, what is the location? So you need some geo coordinates. Got Mapbox. Okay, so you can generate a tile. You can store that tile in Amazon S3. You can issue a link to that temporary Amazon S3 location, a public URL for that tile, to the Facebook chatbot API, and inside the messenger session will pop up the map tile. It's that simple to build. Yeah. It's pretty cool, right? Yeah, I think so. Yeah. Seconds, no. So the cold start latency on Lambda functions, it's normally a couple of 100 milliseconds. So under a fifth of a second is normal. If you've got a very large function, say something that includes a lot of precompiled Java classes, which has a big footprint, then naturally you might have a little bit more latency, okay? And you might see a few hundred milliseconds extra added onto that. But it's still interactive, you know, it's not in the 1 second plus category. It's going to be relatively quick. Yeah, that's a cold start. That's a cold start. And then there's some caching and TTL logic which exists within the platform. We have some optimization techniques that we can talk about. If you've got Lambda functions which start infrequently but perform high value activities and therefore you want to keep the latency down, there are techniques that you can use for that, such as running those functions additionally on a scheduled interval to keep them warm on the infrastructure. There's a little bit of cost, but it keeps them cached and ready to go. And one of the interesting, it's not really a Lambda session, but I'll do that anyway. One of the interesting attributes of Lambda is the more frequently you start your functions, the more likely they are to be cached, the more likely they are to exist across multiple physical or virtual nodes, and therefore the better the performance is. So in contrast to most systems, the more heavily you use Lambda, the better it performs. Question? Yep. So you can express, yeah, you can express however much complexity you feel capable of implementing. Okay, go on. Yeah. So Lex is still relatively new, so I probably couldn't pull out a really good example, but what I could say is on the Echo platform, so within Alexa, people have implemented, you know, these choose your own adventure books. Like, have you heard of choose your own adventure books? Where, you know, you might have read these when you were a kid. There's a British author called Ian Livingstone. He wrote a lot of them. He's a founder of a company called Games Workshop. There's a very famous one called The Warlock of Firetop Mountain. You know, you're in a dungeon. Do you want to go left or right? If you want to go right, turn to page 13. If you want to go left, turn to page 76. People have implemented those. They're a 100, 200, 300 page long game which is implemented as a chatbot on top of the Amazon Echo. That's more sophisticated than most business transactions. Yes. You need to do it intent by intent, but you can already implement the kind of functionality you're talking about. I mean, here's an example, okay? So, because state is maintained across an individual session, I could run a transaction like this, a flow like this. I want to book a flight from London to Tel Aviv, departing here and returning here, okay, return flight maybe. I could write logic inside my fulfillment function which selected and proposed a hotel to a customer and said, notice these are your dates, would you like to book the Rothschild here for these dates? And then I can write that back as long as I issue return an object which has an appropriate conversational close in it to write it back to the customer. And then with a yes, I could default to that booking. So I can write as much presumption into the model as I want to create as a developer. Okay, but I think you've got to balance that off against the customer experience. Do most of your customers want that level of presumptiveness? For some use cases they might, for others they may not. But as a developer you define the flow and you can build that into the system if you want to do so. Okay. How are we doing for time? Yeah, okay. So pricing. There's a free tier. So with text going to get 1,000 requests, 10,000 requests per month for free for a year, 5,000 speech, and then there's differential pricing on text and speech, which is volume based. Okay, so there are costs there to be modeled. As usual, if you need help working through that for a particular application that you're considering building, AWS Solutions Architect should be your go-to people to help you figure out any pricing models that you want to build, and we can certainly help you with that. The team can certainly help you with that. This is the overall systems architecture, which I'm not going to dwell on because I've covered most of this already in conversation. Okay, so I think I've talked about everything that's there. The only thing I haven't talked about is Cognito. If you're not familiar with that, it's an identity management system which allows you to map publicly available identities like Twitter or Google or OpenID Connect identity providers onto IAM roles with AWS IAM policies attached to them. So I could bring in my Twitter handle, E&M, issue a token from Twitter to the Cognito service. It would associate with me a dedicated and unique user ID which would last forever with AWS, and it would also issue me a set of temporary time-limited credentials which are governed by Cognito. This can allow me to use a public ID as a publicly provided ID as a mechanism for establishing short-term authenticated connectivity to an AWS API endpoint. And this is how we would encourage developers to interface with Amazon Lex from our mobile SDKs. So if you're working on Android or iOS devices and you want to build robust identity, Cognito is a good tool for that. Oh yeah, we support that as a provider as well, yeah. Yeah, we support that as a provider. Yep. At the moment, we're US East 1, so we're only available in the US East 1 region today, and we're only available in English as well. So we have obviously a roadmap, and we welcome suggestions about other important regions that we should deploy in. Yes. Yeah. Yeah, not today. Not for the recognition. For the speech generation, as Adrian's already mentioned, we have support for 27 languages, 42 voices, but for the recognition, it's English only. Of course, the Echo, well, it already does German in addition to English, and I'm sure there are plans to do further languages in the future, but I don't know when. You had a question? Yeah, they're all good targets right now. Yeah, they all work. Yeah, they all work. So anywhere where English is spoken, you can use the service today. So let's quickly show you a demo because I'm going to run out of time. So, in common with most new AWS services, we're providing a quick start for Amazon Lex that allows you to get started. So if you don't currently have an Amazon Lex chatbot provisioned within your account and you visit the console, this is what you'll see. Okay, so it provides some information about benefits, and there's also a getting started option there. Okay, and here I have 4 different options. You'll see these options are examples that I've already talked about. So booking a trip, ordering flowers, scheduling an appointment. I can also create a custom bot from here. Okay. If you're using the console for the first time, I would strongly recommend walking through one of the examples. They're very simple, and they will allow you to contextualize what I've talked about in theory into a specific use case. Okay, so do that first of all. I'm going to use the book trip one here, and I'll show you why that is in a second. I've already provisioned another component. So I'm using a service role, and if I'm going to target my service on younger users under the age of 13, there's a legal compliance point here at the bottom. I have to opt out of that, okay? So just be aware of that. And then I'm creating, and at this point, my chatbot is being provisioned into my account, okay? And you can see that here. So while that build takes place, what's happening there is the model for this particular service that I'm creating is being established, and it's been provisioned into API endpoints within the AWS infrastructure. In the background, you can see, although it's grayed out, I'll talk about this anyway, you can see the slots that are provisioned for this particular use case. Pickup city, pickup date, return date, driver age, and car type. It's all to do with car rentals. These are the data types associated with the particular slots, so cities, dates, numbers, indicating they're built-in, so they come from an Amazon provided set of types. Okay, you can't see at the top here, but these are my sample utterances: book a car hire, reserve a car, I think, and make a car reservation. Okay, so this is all to do with the book car intent associated with rental vehicles, right? On the other side, I have another set of intent, sample utterances, and a data model for hotel bookings. Book a hotel. I want make a hotel reservation. Book a night's stay in location. So you can see here I can embed slots inside utterances. Okay, and it will unpack them for me, understand to unpack them. And then I have the data model associated with this intent down here. Yeah.
Will this only support these specific utterances?
No. Those are the starting point for the network, for the neural network. So it's like giving it hints of ways in which I might express this particular intent. But you'll find there's actually a lot of flexibility. Okay, and the more you put in, the more you can enrich the flexibility. I normally aim for 10 sample utterances. Yeah. It's a general purpose pre-trained model. So there's an NLU, natural language understanding pre-trained model. Okay, but building the utterances and the slots is something that you would do for your specific use case. Okay, and you'll see here that I have my test bot. Okay, so I can say book me a car. In which city do you need to rent a car? But you'll notice there's nothing there. Oh, book a car. So maybe it's close to that, but it's a unique utterance. Okay, it's not in the sample utterances, but it still understands what my intent is. This is where the neural network comes into play. The NLU comes into play. Okay, where do I want to? In what city do I want to rent my car? I want to rent it in Seattle. What day do you want your rental to start? I want it to start on Tuesday, and I want it to end on Friday. How old is the driver? I'm sorry to say that I'm 43. Okay, so what would I like? I'd like mid-size. Yes. And that's it, okay? So what you've seen now is a confirmation prompt, okay, which comes in at the end. Okay, I have you down for a mid-size rental in Seattle from date to date. Should I book the reservation? Yes. Ready for fulfillment, pickup date. And this ready for fulfillment is the object that's going to be sent to my fulfillment function, to my Lambda function. I would unpack that within my custom code inside my Lambda function, and that's where I would go about driving or interfacing with an external endpoint to actually make the transaction reality on the external system. And it's that simple to build. Yes? So we have our Amazon US city up here, okay, which does some of that. If you want to have full control over it, then that's something that you would implement in your fulfillment function in validation. Okay, so if there's ambiguity. This is actually one of the things I was thinking about for my mapping tile generator that I'm currently working on. You know, if I say Boston, there's a city in, well, a town in the UK close to where I live called Boston. There's another one in Massachusetts. Which one? So maybe a good follow-on question in my use case might be in which country? Or to provide options, did you mean Boston in Lincolnshire in the UK, yes or no? Did you mean, then by using a mapping API, you could actually sequence the different places in the world called Boston by selection probability and have that built into this fulfillment function.
Right, but does that mean that you need to replace the built-in type completely, or
No, it means that you need, and we're getting on to slightly advanced topics here, but it means that you need code like this, which is the handler, the Lambda function handler that's sitting behind the intent fulfillment, okay? And you can see I'm manipulating attributes here in order to make sure that I have the right data that I need to make my booking, okay? So this is where you'd express the multi-level functionality that was talked about at the back, sophisticated validation capabilities, and write out into third-party APIs. It's all implemented in Lambda Functions. I'm using Python, but you've got those three other options as well. And whatever you can express here, you can implement, yeah. So the speech recognition is a natural part of the platform. Instead of interfacing via the text API that I've showed you in testing there, you would send encoded audio, MP3 audio, for example, to our API endpoint, okay, using a specified set of AWS IAM credentials that are associated with your account. You'd send that to the Lex API endpoint. That audio would then be sent to the ASR and NLU engine, and in front of the process that you've seen here, those things would happen. Okay, so the speech would be unpacked, the intent would be unpacked, and it would be sent onto the Lex service. And for that, you just pay a little bit extra, as you've seen, for your request volume. But the speech is a natural component of the service. Yeah.
How would you show the reach response that you talked about earlier, the Facebook cards?
Yeah.
Is that something you configure within the
Yeah, let me quickly try and show you a little bit about that. So let's just say that I want to connect this particular bot to Facebook. Okay, here are my channels. Okay, Facebook, Slack, Twilio. And for connecting to Facebook, I'm not going to do it here because I have to go and create some creds. But if you click on Learn More on steps to integrate with Facebook here, you're taken to a how-to, which gives you a precise walkthrough of how to create the Facebook webhook that you need to communicate with. And further in the documentation, there's more information about showing cards and responding to cards with touch as well. So it's beyond the scope of this session, but I've experimented with it and yeah, quite extensively myself. Everything's there that you need to know and documented. Okay, I'm running out of time, I think. So in wrap up, oh, there's one other thing to show you actually. Let me just go back. So what I had there, of course, at the end of that sample discussion, you'll recall that I just had the values reflected back to me, right? Because I don't actually have a fulfillment function wired into this particular intent at the moment. What I have is return parameters to client, which is good for debugging, okay? In my account in AWS Lambda, I also have this function already pre-configured in the US East region, which is called Lex Booktrip Python, which you've already seen the source code for here, okay? So this function is already ready to go inside my account and ready to be triggered. So if I change the configuration here and turn on, oh, hang on a second. Oh, get rid of that. No, that was versioning. You can see there, by the way. So I've got a versioning of my function, which you can see I want to operate on latest, which makes it editable. Okay, and then I can fulfill with the Lambda function. I can select my fulfillment function that you've already seen. I can have a goodbye message. Thanks for your car booking. Goodbye. Okay, save intent. And publish, or build that rather. Okay, so what I've done now is moved away from having that simple return of my input values, and I've connected the fulfillment function into this particular intent. So when the intent is fully populated, it will go off and trigger the function, and hopefully this won't take too long. I can show you how the flow differs now that's been done. So just wait a second while this gets pushed. Okay. Book a car in Seattle next Thursday. Oh, didn't get it. Okay. Seattle. Thursday. Friday. 43, and I want mid-size. Okay, so now if I jump into my Lambda console, I'll just look at my dashboard. You should see that I've got a recent invocation. Maybe not. Here we are. So we've got our invocation there, which you can see, and so that's evidence that the fulfillment function is being triggered appropriately, and you'll see we've got logging details here as well. So this is how you sort of close the loop, and you can do some debugging of the function, and you'll see there that the data that I entered around the target city, the dates, the type of car is all present in debug. So my Lambda function got invoked as a result of wiring it in there, and that's where I put my business logic to actually drive interface interaction with the third-party systems that are required to actually make that booking a reality, so that when I get to the airport, there's a vehicle waiting for me. That's the end of my demo, really. Okay, yeah, you got a question?
Just a quick question. In the bot, you initially wrote, I want to book a car in Seattle.
Yeah.
And
It
then
didn't
the
pick it.
bot said,
Yeah.
which city? Why didn't it
Because
put Seattle?
I didn't have a rich enough set of sample intents, sample utterances. So that's where I haven't, in my sample utterances, got an example of using the city directly within the first utterance. Okay, and the way to correct that is to fill out the sample utterances with more derivatives of how the intent might be activated.
Yeah, but if the intent is booked,
Yeah.
and if you're mixing it with the city, then how does the, I mean, how does that, I mean, would it not ask the city?
It did ask the city. I put the city in the intent and it asked me again. So the problem that occurred was it didn't automatically detect the city even though it was in the utterance. And it probably should have done for the correct interface. So that's something that needs to be fixed by having more sample utterances in the data model in the console. So it can be fixed, but there's a change there needed. Okay, so we're out of time. Thank you for attending the session.